Hello, everybody. So today we're going to want to open up to page 38. We are almost done with Unit 2C. We're almost done. So let's open up to page 38. We're going to talk about solving systems of linear equations using the elimination method. So this is something you did learn in 7th and 8th grade, but we're bringing it back. It's a very important method of solving systems of linear equations. All right, so let's all get to page 38. So last week, you all saw how to solve systems using the substitution method, correct? We isolated one of the variables, and then we substituted into the other equation, right? So in this situation, given this example, you could have gotten x by itself, and then you would have plugged this whole thing in for x of the other equation. All right, so I'm just writing that kind of quickly. So the way that we use the elimination method is we actually want to first make sure that the variables are lined up with each other. So you see how my x's are lined up, my y's are lined up, and the constant is lined up. All right, so we want to make sure that they're lined up. So that's good. The equations currently are lined up, so I'm just going to rewrite them. So we're off to a good start. Equations are lined up. Okay, let's read our next piece of information. So we did the first step. Now our next step is to eliminate one of the variables by adding the two equations together. And if it's necessary, we're going to multiply one or both equations by a number so that one of the variables has opposite coefficients. So what do I mean by that? Well, let's just take a look at these equations. I want to see, can I add them vertically and cancel one of the variables? So let's see, can I add the variables vertically? So let's see, can I add these vertically, and will one of my variables cancel? Again, everything is being added. Okay, well, let's see. If we add the two equations together, the whole point is to eliminate one of the variables. So we have x plus 5x is 6x. There's a 1 here. Hold on, there's a 1 here. So we have 6x. We have negative 2y plus 2y. Guys, remember, that part is the opposite coefficients. Negative 2 is opposite positive 2, so that's 0. So do I need to write plus 0y? I do not, so I'm actually going to erase that. I do not. They cancel. Equals, now we're combining like terms here. What's negative 19 plus 1? We get negative 18. So now that we've written our equation, okay, so again, if you want to keep that there just for, filling up that space, that's fine, but it's really just plus 0. So now I have 6x equals negative 18, because this is just plus 0. And we're going to divide both sides by 6. And I'll get x to equal negative 3. Are we done? Did we solve the system of equations? Did I find the solution to the system of equations? No. We did these first 4 steps, but no, we're not done. A solution to a system of equations, right? A solution is x comma y. You only gave me x. So we need to go back and get y. How do I go about doing that? Well, hang on. Here are my two equations. We have x. We need to find y. So now in this step, we need to find y. And I'm going to go with the equation that has the 1 out front of the x. It's just easier, I think. Doesn't matter, though. So I'm going to use this equation, x minus 2y equals negative 19. Could I have plugged x equaling negative 3 into the bottom? Absolutely. It could go into both. It's a good way to check to make sure you did it right. Okay. So we have x is negative 3. So let's see. Let me just clean that up there. So we have x is negative 3. So let's plug that in. I have negative 3 minus 2y equals negative 19. Add 3 to both sides. Sorry, I'm running out of space here. And I have negative 2y equals negative 16. Divide both sides by negative 2. And I get y to equal 8. So there's my solution. There's my solution to the system of equations. It's negative 3, 8. Because we found x to be negative 3 and y to be 8. Now, we want to do a check. You always want to check your solution into both equations. So I'm just going to erase this. I shouldn't have gone into that separate box. Sorry, I wrote a little too big. Now we're going to do our check. So we're going to check both equations. We had the equation of x minus 2y equaling negative 19. And we had 5x plus 2y equaling 1. And we're going to plug in. Here's x. Here's y. Plug them in. Negative 3 minus 2 times 8 equals negative 19. Does negative 3 minus 16 equal negative 19? Yes. So that checks. It needs to check for both. It's not sufficient to work for one and not the other. It has to work for both. It has to satisfy both equations. Okay, it must satisfy both equations. So now let's check here, and let's change it up. We'll do it in purple. We have 5 times negative 3 plus 2 times 8. Again, I plugged in those x and y values from the information here because we're checking and making sure that is, in fact, the solution. And you guys have calculators. You end up getting 1 equals 1. It works for both, so we use the elimination method by just adding vertically because our terms canceled. It worked out nice. There was nothing to multiply. Okay, let's take a look at exercise 2. So now again, here we go. Make sure that the terms line up. So these are the two equations that we're looking at. So let's make sure we have our x's line up, our y's line up, and our constants line up. So this is good. So I'm just going to rewrite my two equations. 3x plus 4y equals 18, and negative 2x plus 4y equals 8. Now again, reminder, the goal is to eliminate one variable by adding the two equations together. And then if it's necessary, which in most cases it is. So if it's necessary, multiply one or both by a number so that one variable has opposite coefficients. So if I look, can I add these equations vertically? Well, let's see. Can I add these equations vertically? Well, let's do it. Add them. So we're adding everything here. 3 plus a negative 2, that's 1x. 4 plus 4, that's 8. And 18 plus 8 is 26. Now, did I eliminate a variable by doing this? Should I have just added those as is? No. So now it is going to be necessary to multiply one or both of those equations by a number. All right, that is going to be necessary. So we just saw adding vertically didn't work. So now, guys, you need to look and see, could I multiply the top equation or the bottom equation by something so that variables cancel? Well, hey, I've got a 4 here and a 4 here. Can I multiply one of these by negative 1 so that the y's cancel? Do I have to multiply the bottom by negative 1? Can I multiply the top? Sure, it doesn't matter. Maybe I'll multiply the top by negative 1. It does not matter. Okay, so maybe we'll multiply the top by negative 1. So let's see. You got to distribute. We'll have negative 3x minus 4y equals negative 18. Nothing changed here, so rewrite it. Nothing changed. And now let's see if we add vertically what happens. Add vertically. Negative 3x plus a negative 2x is negative 5x. Negative 4y plus 4y is 0, right? 0. And negative 18 plus 8 is negative 10. Okay, so we did it. We eliminated one of the variables by multiplying one of the equations by a number, that number being that negative 1, and we had opposite coefficients, right? We had the negative 4 and the positive 4. That's opposite coefficients. That's what we wanted. So now let's write. We have negative 5x equals negative 10 because 0 times y is just 0. Awesome. Okay. Now we're going to solve for one of the variables. So I have negative 5x equals negative 10. Divide by negative 5. And I get x to equal 2. Okay. the next piece is now substitute the value of the known variable into one of the equations. Does it matter which equation? Does not. So let me just write both equations again. We had 3x plus 4y equals 18. And we had negative 2x plus 4y equals 8. So you're going to plug x into one of these. It doesn't matter whether you plug it in the top or the bottom. I think I plugged into the top last time, so let's just plug into the bottom. It does not matter. It doesn't matter. Okay, so we have negative 2 times, here's x. We're plugging in for x. Negative 2 times 2 plus 4y equals 8. And we're solving for y. So we have negative 4 plus 4y equals 8. Add the 4 to both sides. Right? Undo that subtraction with addition. And I have 8 plus 4 is 12. Divide everything by 4 and we get y to be 3. Now, have we solved our solution to the system of equations? I've got an x and I've got a y. Yes, we did. That's the solution. 2, 3, because x equals 2 and y equals 3. So now we just have to go back and check. We just want to do our little check, make sure everything worked out okay. So I'm just erasing that for some space. So let's do the check. We got to check both equations. You cannot just check one. You got to do both. I don't care if it works for just one of them. It has to work for both of them. For it to satisfy one is not enough. It needs to satisfy both equations. All right, and now we're just plugging in. We have 3 times 2, because that's x, plus 4 times 3, because that's y. I have 6 plus 12. Does that equal 18? Yes, it does. So that checked. We're not done. Now I need to check the second equation. So I have negative 2 times 2 plus 4 times 3. Does that equal 8? I have negative 4 plus 12, and that does, in fact, equal to 8. So our check worked out. There's my solution to the system of equations. Okay, let's move on. Let's flip it on over to page 40. Now we're going to start to take a look at some more challenging problems now that we've gotten into the rhythm of how to solve a system of equations using elimination. Okay, so let's take a look at exercise 3 together. So we're going to do exercise 3 together. So again, the whole objective is to eliminate one of the variables, elimination method. So can I just add these vertically? Let's see. I'll get x. We've got plus 4y equals negative 9. I just added everything vertically. And no, none of the variables canceled, so that doesn't work. You can't just add vertically here. That means we are going to need to multiply the top, bottom, or both by a number. Remember, guys, the goal is to get the variable to one of the variables to cancel. So how can I get, let's choose x. How can I get x to cancel? What number needs to be here in order for these things to cancel? Right now I have 2x minus x. I need it to become 0. What number needs to be here to make it 0? 2, right? 2x minus 2x is 0. So we need to multiply this denominator by 2. Multiply the denominator by 2 because now, okay, let's do our distribution. Distribute. So rewrite the first line. Nothing changed here. 2x plus y equals 3. And now do the distribution here. The line below it will read 2 times negative x is negative 2x. 2 times a positive 3y is positive 6y. And 2 times a negative 12 is negative 24. You got to distribute throughout the whole thing. Okay, throughout the whole thing. Okay, so now this is what I'm left with. And now let's see, can we add vertically? Let's see what happens. 2 plus a negative 2 is 0. So that's just 0x. Y plus a positive 6y is 7y. There's a 1 out front. And 3 plus a negative 24 is negative 21. So these terms canceled, right? 0x is just 0. So I have 7y equals negative 21. And we're solving, in this case, for y. So let's divide everything by 7, and we'll get y to be negative 3. Done? Finished? No. You need to solve this system, right? We got to find the solution. Solution is x comma y. X comma y. Right now you just got me y. I need x. Again, to find x, plug back into either the top or the bottom equation. It doesn't matter. I'll go with the top. Sure, it does not matter. So I have 2x plus y equals 3. We're plugging in for y here. 2x plus negative 3 equals 3. Add the 3 on both sides. I have 2x equals 6. Divide by 2, and I get x to equal 3. So there's my solution, 3 comma negative 3. And you always want to go back and do that check. I'm not going to do the check right now just for time's sake, because you guys can do that on your own. I know you know how to. Just plug x and y back in to both equations, right? X and y go into both equations. All right, but I want to take a look at now question 5 next. Okay, so we solved this using elimination. Let's take a look at question 5. Okay, so for question 5, I'm just going to rewrite the problem. We have x plus 4y equals 1. Make sure you rewrite the problem correctly. That's important. We have 5x minus 6y equals negative 8. And again, let's see. Can I add vertically? The whole objective is to use the elimination method. Eliminate one variable. Eliminate one variable. So let's see. If I add vertically, add them all vertically. Add them all vertically. I have x, there's a 1 out front here. 1x plus 5x is 6x. 4y plus a negative 6y is negative 2y. And 1 plus a negative 8 is negative 7. So nope, didn't work. Nothing canceled. So that was not the way to go. So that means we're going to need to multiply one or both equations by a number. So let's see, let's try this again. That didn't work because no variables canceled. Well, let's see. I want to cancel one of the variables. Okay, now look over here at y. This seems a little bit more difficult to cancel because I've got a number in front of y that's not 1. Right, I've got 4 and I've got negative 6. But if I look over here at x, okay, if I come over here to x, do you see how I have the number in front of x being 1? That's really nice. What do I need to multiply x by so that these terms cancel? What do I need to multiply x by so that these terms cancel? What does this need to be? What plus 5 is 0? What is the additive inverse of positive 5? 5 plus what is 0? Negative 5. So if this is a negative 5x, those terms cancel. So we're going to multiply the numerator by negative 5. Again, the objective, people, is we want to get the x's to cancel. The only way the x's are going to cancel, the only way these x's will cancel, is if the number in front of x here is negative 5. So let's do it. Okay, so let's distribute. I just rewrote it out, make it cleaner. I'm going to rewrite this line now as negative 5x. We have negative 5 times 4y is negative 20y. And I have negative 5 times 1 is negative 5. Nothing changed with this line, so I'm just going to rewrite it. That's 5x minus 6y equals negative 8. We add vertically, add all of these things. Negative 5x plus 5x is 0x. That was the purpose, get them to cancel. Negative 20y plus a negative 6y is negative 26y. And negative 5 plus negative 8 is negative 13. We're getting y by itself. So I have negative 26y equals negative 13, right? 0 times x is 0. And we divide both sides by negative 26, and we get y to equal positive 1/2. You guys have calculators, right? A negative over a negative is a positive. Negative over a negative is a positive. I don't need to write that, though, hopefully. Hopefully, we can just write that as just 1/2. We're almost done. We need to solve for x. We're not done because a solution to a system of equations is x comma y. All you gave me right now is y. So we got to plug back into one of the equations. And let's go with the top one. It does not matter which one you plug back into. So we have x plus 4y equals 1. Plugging this in for y, x plus 4 times here's y. 1/2 equals 1. You have calculators. 4 times 1/2 is 2. Okay, to undo this addition, we subtract, and we'll get x to equal negative 1. So my solution to the system of equations, because we got to write it as x comma y, is negative 1 comma 1/2. Alrighty, I hope you found this video helpful. Make sure when we use the elimination method, we're looking to eliminate one of the variables using those steps I've taught you.